All right, guys, there we got theorems about zeros of polynomial functions. Really the first part of two today, and hopefully it won't be too bad. Let's get it and see. The fundamental theorem of algebra, the fundamental theorem, says that every polynomial that has degree n, which means it's the biggest exponent, whatever your biggest exponent is, has at least one zero in the set of complex numbers. So every polynomial of degree, some kind of positive degree, or degree bigger than one, has at least one zero. So what we're going to do is we're going to write some of those functions today. They're going to give us what the zeros are, and we're going to kind of write them. So the first one says a polynomial function of degree 3 has zeros 1, 3i, and negative 3i. So what we're going to do is we're going to write those as factors, because those zeros came from factors. Like the 1 came from x minus 1. The 3i came from x minus 3i. The negative 3i came from x plus 3i. And all you have to do to these things today is just multiply them all out and see what you get. That's a polynomial. So I'm going to multiply these two first because they're conjugates. And remember, when you multiply conjugates, you can just do foo. So that's what I'm going to do. If I do first here, x times x is x squared. If I do last, negative 3i times positive 3i is negative 9i squared. Don't forget what that 9i does. Sorry, that I squared does. The I squared does to the 9. It's really negative 1. The I squared is negative 1, which makes it a plus 9. So all I have left to do now is FOIL. So I'm going to do first, which is x cubed. Actually, I'm going to go a little bit different order here to make my exponents be in right order. I'm going to do FIOL. Inside is negative 1x squared. Outside is positive 9x. And last is negative 9. And guys, that's it. So all we're doing here is they're going to give you zeros. You're going to write them as factors, because that's where the zeros come from. They come from making the factor 0. And just multiply all the factors out to get your function. Okay, two big theorems here. First one says if a plus bi is a 0, then a minus bi is 0. For example, if you know one answer is 5 plus 2i, automatically another one's 5 minus 2i. Complex or imaginary answers or zeros never come in singles. They come in conjugate pairs all the time. Same thing for the second theorem. It says irrational zero theorem. If a plus c on the square root of b is a 0, a minus c on the square root of b is 0. Think about the quadratic formula. X equals negative b plus or minus the square root. We always have plus or minus signs in front of our square root. That's why that's true up there, and this is why this is true down here. So let's see, you get this as an answer. 3 plus the square root of 2. Automatically another 0 is 3 minus the square root of 2. If you had square root of 5 as a solution or a 0, negative square root of 5 would be a 0 or solution. So they always come in conjugates. Conjugate pairs. All right, suppose that a polynomial function of degree 6 has zeros negative 2 plus 5i, negative 2i, and 1 minus square root of 3 as 3 of its zeros. Find the other one. So, like we just said, everything, they always come in conjugates. So if negative 2 plus 5i is a 0, so is negative 2 minus 5i. If I'm looking at this one, if negative 2i is a 0, positive 2i is a 0. And lastly, if 1 minus the square root of 3 is a 0, 1 plus the square root of 3 is a 0. Now don't get confused. It's only true with radicals and with complex numbers, with the I. If you know one number is 6, a solution is not negative 6. That's not how it works. It has to be either radical, and really I is a radical, or a complex number. Those come in conjugates. All right, last slide here. Doozy though. Find a polynomial function of lowest degree with rational coefficients negative square root of 3 and 1 plus I. So here's what my answers really are, or zeros really are. If negative square root of 3 is a 0, that means positive square root of 3 is 0. If 1 plus I is a 0, automatically that means 1 minus I is a 0. So what I'm going to do is I'm going to write them all as factors. So I'm going to say x plus the square root of 3. That's where the first one came from. X minus the square root of 3. That's where the second one came from. That's where it gets crazy. X minus 1 plus I. And also x minus 1 minus I. Okay. And the fun part is I get to multiply all this out, which is really not as bad as you think it is. Or maybe it is. I don't know. Okay, so the first two, those are conjugates. So I'm going to do foo. I'm going to do first last. So I have x squared minus, if you do square root of 3 times square root of 3, that's just 3. So that's done, those first two. Now the second two, I'm going to take that minus sign inside there and kind of distribute that, make it x minus 1 minus I. So I just distribute that minus sign. Same thing on the second one, x minus 1 plus I. And what I'm noticing is when I do that, is when I start to multiply this next step, this right here is x minus 1, x minus 1. Then I have a minus I and a plus I, because those are conjugates. X minus 1 is the first term, positive I, negative I is the second term. So I'm going to do foo again. Okay, so I'm going first, which is x minus 1 squared. Not sure why I changed colors right there. Minus I squared. And I'm going to multiply that out. This is getting a little bit lengthy, I know, but it's just how it is. So got to kind of deal with it. X squared minus 3. Okay, if I do FOIL here, I'm going to square this one. I've already done. I'm going to do the first one. I'm going to do x squared minus 2x plus 1. Now that I squared is negative 1, and it's minus negative 1, which is plus 1. So now I have x squared minus 3 times x squared minus 2x plus 2. All right, and I'm going to multiply that out. It's going to take me 2 more lines. I know it's long, but 2 more lines and we're done. I'm going to distribute this x squared all the way through the second parentheses. I get x to the fourth minus 2x cubed plus 2x squared. And then I'm going to distribute the negative 3 all the way through. Negative 3x squared plus 6x minus 6. And combine what I can. X to the fourth, there's nothing to combine. I can't combine any 2x cubes. I do have these two terms right here. 2x squared and minus 3x squared. That's minus 1x squared plus 6x and minus 6. And that's it. That's all you got to do on that one. I know you're thinking, that's all? But that is. Hope it made a little bit of sense. Watch it again if you need to. Just that one slide I think is the worst. We'll work on these things when you come in tomorrow. See you then.